Welcome to the class of Advanced Network Analysis. It starts with the first topic, Basic Circuits Elements. But before we come to these basic circuit elements, let us try to know what is a circuit and what is a network. Network. Network can be defined as any combination or interconnection of network elements like resistors, capacitors, or electrical energy sources okay. Combination and interconnection of elements like the resistors, capacitors, inductors, or energy sources, okay. It's known as a network. And what is a circuit? Circuit is also a network, but it should have a energy source and it should be closed, okay. So circuit is a network, okay, but it contains a energy source, okay. So circuit is a closed energized network, okay. Now when we say network, it need not contain any, it may contain or it may not contain an energy source, but when we say network, it should have an energy source, either it can be voltage source or current source, okay. So that's why circuit must contain an energy source. Therefore you can say that all circuits are networks, but all networks are not circuits, okay. All circuits are network, but it is not necessary that all networks are circuits, okay. So please note this one, what is a network, what is a circuit, okay. And then let's come to some other term, which is loop and mesh, okay. We have two terms, loop and mesh, okay. For that we need to consider a simple circuit to define what the loop is and what a mesh is and what is the difference between loop and the mesh, okay. So let us take a simple circuit. consisting of some circuit elements like the voltage source, current source, and of course resistors. Okay. So we can see two voltage sources till now, with some resistors. And here is a current source I. Okay, let us name the components here: R1, R2, R3, R4. Okay, this one is R5, R6, R7, and we have voltages V1, V2, then current source denoted by capital I. Okay, and yes, some connecting points term as A, B, C, D, E, F, G. Okay, yes, what we are supposed to define: loop, mesh. Yeah. So when we define loop or a mesh, how do we define? A loop or mesh, it denotes a closed path. Okay, it denotes a closed path obtained by starting at a node, and returning back to the same node okay, to the same node to the same node through a set of connected circuit elements like R1, R5, R3, etc. Okay, without passing any intermediate node more than once. Okay, so you see we have some loops here. Okay, when I was defining loop, we come to a term which is known as node. Okay, what is a node? Node is a point. It is a point in a circuit where two or more elements join. Okay, node is a point in a circuit where two or more elements join. For example, we have node A, node B, node C, D, E, F, G. Okay, it's a point in the circuit where two or more elements join. Okay, for example, you take node A. What are the elements which are joined by this node A? This R1 and B1. Okay, so that is a node. Okay, similarly when we say node B, it connects R1, R5, okay, and of course R7 also. Okay, so that is the thing. Yeah, now coming back to our definition of loop and a mesh. Okay, so when we say loop, it is a closed path obtained by starting at a node and returning back to the same node, okay, through a set of connected circuit elements without passing through any intermediate node more than once. Okay, so let us see some loops, example of some loops here. Okay, example of some loops here. So we have loop example, let me write here. Yes, let's take the example of this loop A, B, E, D, C, A. Okay, so this is a loop. Okay, it starts from A, then it goes to B, then it goes to E, then it goes to D, then it goes to C, and it goes back to A. Okay, so it's a closed path starting at node. Starting node is A and returning back to the same node. Okay, A, B, E, D, C, A. Okay, through a set of connected circuit elements. Okay, those circuit elements are R1, R5, R3, R2, B1, without passing through any intermediate node more than once. Okay, that means the node should be passed only once. Okay, not twice. Okay, so A, B, E, D, C, and coming back to when we go to this, we are going it only through once. Okay, the intermediate nodes are passed only through once. Okay, so this is one fine example of a loop. Okay, another example is, let's take the loop formed by another example is, let's take, okay, one more example. Okay, let's see this one. C, D, E, B, G, F, C. Okay, let us see the path formed by this. Okay, it starts from where? Okay, C to D, then D to E, then E to B, then E to B, C D E B C, C D E B, G F C. Okay, then it is going to G, then it is going to F, and returning back to the starting node, that is C. Okay, so this is one example of a loop. Okay, starting from C, then going through certain circuit elements like R2, R3, R5, R7, R4, V2, and returning back to the starting node, that is C. Okay, so this is also one another example of loop. Okay, now what is mean by mesh? What is mean by mesh? Mesh. Okay, let's see what is a mesh. Mesh is the smallest loop. Okay, mesh, you see, it is the smallest loop. Smallest loop. So when we say smallest loop, we mean that it does not contain any other loop. A loop inside a loop is not possible. Okay, a loop inside a loop is not possible, where in case of loop, you can say there can be a smaller loop inside a bigger loop. Okay, but in case of mesh, it cannot contain any other loop within it. So in other words, mesh is the smallest loop. Okay, for example, this is the example of loop, and the example of mesh is, for example, let's go to the a mesh is a loop. Okay, but a mesh is also the smallest loop. Okay, So let's see the example of G, E, B, G through R7. G, E, B, G. G, E, B, G. Okay, so that means starts from G, then B, then B, G, E, B, and coming back to G. Okay, so within this you cannot find any other loop. Okay, whereas you check this one, A, B, G, F, C, A. Okay, this part, this is the mess. This is not a mess because we can find some other loops inside this loop. Okay, so this part A, B, A, drawn by this purple line, A, B, then containing this current source I, then G, then F, then C, and back to A. Okay, this is a loop, but it is not a mesh. Okay, because it consists of some other loops inside this loop. Okay, so let's go to the next page. Okay, yeah, we were talking about the node. And when we say node, when we define node, we also need to define what is a branch. BRANCH. What is a branch? So a branch is a path. It is a path. It is a path that connects two nodes. Okay. And yes. So suppose we have a simple circuit here. A, B, C, D. Let's take this example. So this one is, okay, let it be R1, R2, R3, B1, C. This is for the node C. Okay, node C. And this is the capacitance C. Okay. So where is the branch? So this is a branch. Okay, a path that connects two nodes. They are connecting node A and B. Okay, this is also a branch. It connects two nodes B and C. And this is also a branch. It connects node D and C. And this one is also a branch. It connects node A and D. And this one is also a branch because it connects nodes B and C. And the circuit element here is R3. Okay. So we are done with defining some basic terms that are required in this semester. So let's come back to our first topic of the unit 1. This is the basic circuit elements. Okay, so we know what is a circuit. Okay, a closed energized network is known as a circuit, and in these circuits they are commonly divided into two basic types, and they are active element and passive element. Okay, active element elements and passive elements. So circuit is mainly classified into two types, active elements and passive element. And when we say active element, they are capable of generating electrical energy. Okay. In electrical engineering, generating or producing electrical energy actually refers to conversion of electrical energy from non-electrical form to an electrical form. Okay. So similarly, energy loss would mean that the electrical energy is converted to a non-useful form of energy and not actually loss. Okay, because we have to follow the law of conservation of energy. Okay. Now, some examples of active elements include like the voltage source and the current source. Okay, voltage source such as battery or generator, then current sources also. Okay, current source. Okay. Now these active elements, they can be either ideal voltage sources or current sources. Okay. Then let's see the passive elements. What are passive elements? Now, passive element is one which does not generate electricity but either consumes it or stores it. Okay, does not generate electricity, but either consumes it or stores it. Okay, we have examples like the resistors, inductors, capacitors, etc. Okay, and also diodes and transistors are also passive elements. Okay, now passive elements, they can be either linear or they can be non-linear. Linear means that obey a straight line law. Okay, or you can say that obeys the superposition principle. Okay, that obeys the superposition principle. Okay, and non-linear means those who do not obey the superposition principle. Okay, these resistors, inductors, capacitors may be linear or nonlinear, while diodes and transistors are always non-linear. So let us describe each the non-linear components. Let us try to rewind these basic things that you have already studied in your previous semester here again. Okay, passive circuit elements. We will consider these three passive circuit elements again. Resistors. Symbol is of course this one. Now when we say resistor, we define this term electrical resistance. Electrical resistance. Okay, it is a measure of degree to which an object opposes an electric current through it. Okay, and of course its SI unit is which opposes electric current through it. Okay, a measure of how much it opposes the flow of electric current through that material. Okay, now the SI unit of electrical resistance is of course ohm. Okay, yeah, and the reciprocal quantity of resistance, okay, is the electrical conductance, and SI unit is Siemens, noted as capital S. Okay, and we are aware of this Ohm's law also. Okay, B is equal to IR or I is equal to B by R, where R is the resistance of the object, B is the voltage across the object measured in volt, and I is the current through the object measured in ampere. And there are some factors which affects the resistance. Okay, there are some factors which affect the resistance. Factors affecting the resistances. One is length of the material, length of the material. Resistance of a material is directly proportional to the length of the material. Okay, directly proportional to the length of the material. Then you have cross sectional area, resistance of a material is inversely proportional to the cross sectional area of the material. Okay, inversely proportional. Then number third is type and nature of the material. Type and nature of the material. The resistance of a material is dependent upon the nature of the material, in the sense that it depends upon the number of, okay, it is depending on the number of free electrons present in the materials. Okay, for example, for a conductor with plenty of free electrons, the resistance is least. Okay, for example, in case of conductor, there is plenty of free electrons. Okay, free electrons are there, for that's why your resistance value is low. Okay, resistance value is low. Whereas in case of insulators, and of course we know in insulator they do not have free electrons, and in this case you will find that the resistance value is larger as compared to that of the conductor. Okay, so that's why resistance value also depend on the type and the nature of the material. Okay, then